guys, today I want to talk to you about the improvements on this voice recognition software. If you have seen the previous video, that is the version 1. Basically in this version 1 what we do is we press a button. So when we press a button, what I do is record 3 seconds of audio. So once these 3 seconds of audio are registered, this frame of information is passed to the function or procedure to do the analysis of this word and try to identify which word have been said. Okay, so in this version 2 there is basically 2 major components that have improved with respect to the previous version, which are in first place now is the audio capturing is real time. There is no more the need to press a button every time you want to say a word. So now the software will be continuously reading from the input, which is the microphone in the computer. And the second component that have improved is the algorithm that does the decision of which word have been said. For the decision algorithm, actually now I'm using neuronal networks, which is a method that works very well to identify patterns. But let me show you how is the interface of this version 2, and I want to talk to you a bit more in depth about some of the aspects of the processing to carry out. Well, this is how the graphic interface looks like for the version 2. So basically we will have an area for us to do the graphic representation of different functions, but I will go through that later on. Here we will choose all the functions that we want to see on the graphic. So on the graphics, basically we have the level, the signal, and we are representing the 3 last seconds of audio. Okay, so let's start the application and see how it performs first, and later I will go in a more deep explanation of some of the process that I carry out. Okay, let's start with it. Oh, sorry, I need to enable all the graphics first. 1, 2, 3, 4, 5, 4, 5, 1, 2, 4, 3, 5, 4, 2, 1. Okay, as you can see, it's quite accurate. The success rate as per this test is 100%. Okay, so let me explain you more about all the different graphics and what I'm doing here. So on the graphic side, we are representing the signal, which is the blue color. In red color is the zero crossing rate. Later I will go through. And the green color that maybe cannot see well is the contour of the signal. So let's go through the contour of the signal first. One. So this is the green color graphic. It basically is the contour of the signal. So this is very useful for us because with this we can specify where the word start and finish. So basically I use this to extract the what is just the word only for the post processing later on. So basically we define a threshold which will be above the noise, the ambient noise. So when the our contour of the signal is above this threshold, means that there is a significant audio signal there. So we will analyze this signal. Okay, let's see the contour for another of the words. 2. Okay, this is the contour for the word, the number 2. Let's see another one. 5. Okay, so basically we can say that the contour of the signal will be different for different words. So one of the parameters that I'm using, for example, is the energy of the signal. So when we say number 5, for example, we see the maximum energy is around this area. Okay, so basically we can see from here how is the energy distribution within the word. Okay, so let's see with the zero crossing rate. Okay, for the zero crossing rate I may need to activate the signal as well. One. Okay, as I said, the red color function is the zero crossing rate. The zero crossing rate is a very simple concept. It just is the how often the signal cross through the axis through 0, right? So this gives us an idea of the frequency of the signal. So this zero crossing rate is directly related to the frequency of the signal. When the signal frequency is high, so the crossing rate, the zero crossing rate will be high, and when the frequency of the signal is lower, the zero crossing rate will be lower. So with this zero crossing rate, it tells us for different sounds we can get different frequencies, so we can discriminate different sounds within the word. Okay, so let's see some examples. For this case, for example, we'll say 1. For example, for when we pronounce the N, M, the zero crossing rate will become very low. Let's see some example. M. Okay, when I pronounce M, the initial portion is due to the vowel E when I say E. So, and the final portion is due to the M, the M. So when we pronounce the M, the zero crossing rate will be very low. For the signal also, we can see when we are pronouncing vowels, usually the power of the signal is the energy of the signal is quite high. Okay, so let's see another case. End. Okay, when we pronounce N, okay, we see how the N got a very low zero crossing rate as well. We can see another cases, for example, when we pronounce the number 2. Let's see example. 2. When we pronounce the number 2, there is a explosion at first. So when we are pronouncing this is so-called explosive consonants like P, T, all this kind got a lot of air coming out, right? So due to this, the frequency will be very high. And that's why we see this peak. on the zero crossing rate, right? And also we will see the same effect when we pronounce like S, because the S is a very high frequency. So let's see one example, very good. Mushroom. So when we pronounce mushroom, okay, we can remember I say that when we pronounce M, the zero crossing rate will be very low, right? Also at the end of mushroom there is another M, also the zero crossing rate will be very low. Then when we are pronouncing the SH, sh, is a very high frequency. So with this actually we can identify the different parts of the word. Currently for this analysis, I'm not using the zero crossing rate yet. Basically what I'm doing is just take the whole word, extract a few parameters and pass through the neuronal networks. Okay, so this is all. I have give you some tips, so if you are doing some audio recognition software, from here you can get quite some ideas. Okay, thank you very much for watching. See you next.